Hello everyone and welcome back to the channel. In this video we're going to start exploring the first of several equivalent expressions, the expression a plus or minus b to the power of 2. These formulas are very basic and they help us multiply numbers quickly, so it's very useful to remember them by heart because the exercises will involve these formulas a lot from now on. Okay, we're going to use these formulas almost every time we do algebra in the future. So the first one is a squared plus or minus 2ab plus b squared. Now let's try to derive this formula by multiplying the two polynomials a plus b times again a plus b. Okay, you remember from last video we multiply polynomials by the principle each with each, so each term of the first bracket is going to be multiplied with each term of the second bracket. So I start multiplying. A times a is a squared plus ab plus b times a is again ab plus b squared, and now these two monomials are similar and therefore I can add them together and I get a squared plus 2ab plus b squared. Okay, what about the second formula? If I have a minus, a minus b times a minus b, I get a squared minus ab again plus b squared, and therefore these monomials are similar. A squared minus 2ab plus b squared. Okay, so this is the algebraic method of deriving this formula by multiplying two polynomials, but these formulas were known in ancient Greece, and the Greeks thought of algebra mostly in terms of geometry. They wanted to give a geometrical interpretation to each major formula. The purely algebraic method of deriving these formulas is something more modern. It comes after the Renaissance, after René Descartes did his major works on the coordinate system. But let's try to give this geometrical interpretation of the formula a plus b to the power of 2 as the Greeks thought of it. Okay, so what we're going to do, we're going to start, so this is geometrical interpretation. We're going to start with a square which has sides a plus b. Okay, this is a square, and now we're going to indicate where is the length a and where is the length b. So I'm going to put a line here. This is length a and this is b, and I'll do the same here. This is length a, this is b, this is a, this is b, and this is a and this is b. Okay, and now if I connect these lines, you see that I have divided the square into 4 regions. One square here which has an area of a squared. I have a smaller square here which has an area of b squared. Okay, and then I have 2 rectangles which have areas a times b, and here I have a times b as well, and therefore the area of the big squared, which is the side to the power of 2, a plus b squared, is going to equal the sum of the areas of these 4 regions. So a squared plus ab plus ab plus b squared, which is the same formula, 2ab plus b squared. Okay, and this is the geometrical interpretation. Now this is a little abstract because what is a and what is b in each particular case. Now, no matter what terms or items we have in the bracket, we are going to think about this formula in terms of the first term and the second term, no matter what they are. Okay, so thinking about the formula. So basically the way we remember it, the way we think about it is this: first plus or minus second to the power of 2 is the first to the power of 2 plus or minus 2 times the first times the second plus the second to the power of 2, okay? No matter what the items are. So let's give a few examples. Let's say I have 2x plus 1 to the power of 2, okay? So this 2x is my first and this 1 here is my second. So I do the first to the power of 2, this is first to the power of 2, plus 2 times the first times the second, plus the second to the power of 2. So this is 2 times my first, this is my second, plus this is my second to the power of 2. And if I want to open the brackets and present the polynomial in standard form, I'll get 4x squared plus 4x plus 1, okay? Let's do another example. What about 3x minus 2y to the power of 2, okay? I use the exact same principle. I get my first to the power of 2 minus 2 times my first item, my second item, plus my second item to the power of 2. And I open the brackets, I get 9x squared minus, now I multiply 2 times 3 is 6, times 2 is 12, 12xy plus 4y to the power of 2. And this is the standard form. Make sense? Okay. Let's do a few more examples actually. Let's do 2x to the power of 3 minus let's say 3y to the power of 2, okay? It doesn't matter what the items are, I use the same principle. So this is 2x to the power of 3, the whole thing to the power of 2. This is my first to the power of 2 minus 2 times my first times my second item plus my second item to the power of 2. Remove the brackets. You know properties of power numbers. Everything is to the power of 2 in the bracket. So it's 4x to the power of 6 minus 2 times 2 is 4 times 3, again 12x to the power of 3y to the power of 2 plus 9y to the power of 4. Okay, and this is the standard form. What about this one? How would I do if I have three numbers, a plus b plus c to the power of 2? I have to choose here which item will be my first and which one will be my second, and I have two options. Either I take this here as the first and this one as the second, or I do the reverse. I take this one as the first and this one as the second. Okay, it doesn't really matter, I'll get the same result. So let's choose this approach. My a is the first and b plus c is my second item. So this is going to be a squared plus 2 times the first times the second plus the second to the power of 2. Okay, so I get a squared plus 2ab, I remove the bracket, multiply each with each, plus 2ac plus, and I apply the same formula to b plus c to the power of 2, b squared plus 2bc plus c squared, and this is a standard form. Okay, so far so good. Let's do some properties. So property 1, this is a very important property which can be applied in many cases, a minus b to the power of 2 is the same as b minus a to the power of 2, which means that I can exchange the signs of the items and the result does not change. Let's see how we prove it. The way I prefer to prove this is by the third method of proving equivalent expressions from the last video. I want to start with this and get to the right side without modifying the right side, okay? So what I'll do is this. I'll start with a minus b to the power of 2. Then I'll take a minus outside of bracket and I'll get this expression, minus b minus a to the power of 2, okay? And now the power of 2 is applied to every factor in the bracket. So this is going to be minus 1 to the power of 2 times b minus a to the power of 2, okay? And minus 1 to the power of 2, as you know, is just 1, b minus a to the power of 2. So this is the same as b minus a to the power of 2, okay? The exact same logic is valid for the expression minus a minus b to the power of 2 is the same as a plus b to the power of 2, okay? I can do the exact same thing, proof, minus a plus b to the power of 2, this is minus 1 to the power of 2, times a plus b to the power of 2, which is a plus b to the power of 2, okay? Minus a minus b to the power of 2 is equal to this. Makes sense? Alright, so if this makes sense to you, let's do some exercises, shall we? Which one do we choose here? Let's choose what? This one here, 3, the first example, a squared plus 1/3 to the power of 2. Apply the formula, a to the power of 4 plus 2 times the first times the second plus the second to the power of 2, okay? So this is a to the power of 4 plus 2/3 a squared plus 1/9, okay? Which one do we choose next? Let's choose the fifth, the 5, the second example, 2x plus y plus 1 to the power of 2. 2x plus y plus 1 to the power of 2. Now I can actually just do this example by this formula, which I also can remember it. So if I have 3 numbers in the bracket to the power of 2, each one of them is to the power of 2, and then I do 2 times all possible combinations. So 2ab, 2ac, 2bc. This means 2 times the first times the second, plus 2 times the first times the third, plus 2 times the second times the third. So I can remember this formula also, and I can apply it here. I get the first to the power of 2, plus the second to the power of 2, plus the third to the power of 2, plus 2 times all possible combinations. First times second, I get 4xy, plus first times the third, 4x, plus the 2 times the second times the third, 2y, okay? And this is the standard form. Makes sense? What about let's do the seventh, the first, okay? So I get 1/3 a squared b minus 1/5 x squared to the power of 2. The same principle. 19 a to the power of 4 b to the power of 2 minus 2 times the first times the second, 2 times 1/3 a squared b. This is the whole thing is the first, this whole thing is the second, okay? So 2 times the first times the second, 1/5 x to the power of 2 plus the second to the power of 2, 125 x to the power of 4. Makes sense? So this is going to be 1/9 a to the power of 4 b to the power of 2 minus 2/15 a squared b x squared plus 125 over 25 x to the power of 4. Okay, that's it. Which one do we choose? Let's do this one here. 0.8 x to the power of 3b minus y to the power of 3 to the power of 2. This is 0.64 x to the power of 6 b to the power of 2 minus 2 times 0.8 is 1.6 x to the power of 3 b y to the power of 3 plus y to the power of 6. Okay, all right, let's do the 8 the second, x minus y minus z to the power of 2. Each of them to the power of 2, x squared plus y squared plus z squared, and then I do 2 times the first times the second, but now because I have the minus here, I can rewrite the formula in the following way: x plus minus y plus minus z to the power of 2. Therefore, I'm treating the second as minus y and the third as minus z, okay? And now when I do 2 times the first times the second, I'm going to multiply 2 times x times minus y, which is going to give me minus 2xy. Then I do 2 times x times minus z, which is going to give me minus 2xz, xz here. And then when I do 2 times minus y times minus z, this is going to give me plus 2 times yz, okay? 2 times yz. And this is how I remove these brackets. Let's do some exercises with concrete numbers. How do we calculate, for example, 42 to the power of 2? Let's do this one. 42 to the power of 2 without a calculator. Well, I use the exact same formula. I do 40 plus 2 to the power of 2. So 40 to the power of 2 is 1600 plus 2 times 40 is 80 times 2 is 160 plus 4. So I get 1764. Okay, and you can check with a calculator that indeed 42 times 42 will give me 1764. Let's do one more with numbers. What about this one? 198 to the power of 2. 198. So this is the same as 200 minus 2 to the power of 2. 200, this is 4 with 4 zeros. So this is 40,000 minus 2 times 200 is 400 times 2 is 800 plus 4. So this is 39,204. 39,204. That should be correct, right? Let's check it. 198 times 198. Yep, 39,204, and that's it. Makes sense? Let's do one last exercise with more involving expressions. Let's do number 16 here, okay? So I get minus x minus y to the power of 2 plus 5, 1 minus x to the power of 2 minus 3, 1 y minus 1 to the power of 2. So this is minus. First, remember, squaring or powering a number takes precedence over multiplication. So first I do the powering of the brackets, I apply the formula, and then I remove the brackets and exchange the signs here. So x squared minus 2xy plus y squared. Again, the same. First I have to power the bracket and then I multiply by 5. Powering is before multiplication. So 5 times y 1 minus 2x plus x squared minus 3 y squared minus 2y plus 1. And now I remove the bracket. Minus x squared plus 2xy minus y squared plus 5 minus 10x plus 5x squared minus 3y squared plus 6y minus 3. Okay, and now I add the similar monomials. 5x squared minus x squared is 4x squared, minus y squared minus 3y squared is minus 4y squared. And I think that's it except for the numbers. I have 5 minus 3. So I just copy the rest, right? Plus 2xy minus 10x plus 6y, and at the end I get plus 2. I have no more similar monomials to add together. Okay, makes sense? Alright guys, thank you so much for watching this video. Next video will be about the formula a plus or minus b to the power of 3. If you have any questions, let me know down in the comments below. Like and subscribe, and I'll see you in the next one. Bye for now.